Okay, welcome to our second lesson on compound interest. So this is our second lesson in financial applications, and we're going to be looking at specifically different types of compound interest. So the learning goal is to be able to solve compound interest problems with and without technology. So we're actually going to look at the TBM solver. Um, it's I'm just going to talk about it on a slide. In class, we'll actually have some time to look at what we input. But so the main focus of this lesson really is going to be doing it by hand, but we actually do work with the TBM solver. So question here: if you were to invest $1,000 at 4% per year compounded annually, what percent per quarter would you have to invest it um, at to have the same amount at the end of 2 years? So the 4% is per year. So the question is what percent per quarter? Um, And if you think about 1% per quarter, um, the 4% per year compounded annually is 4% per year. 1% per quarter actually won't get it to you. Um, what the per quarter means is it's actually, when we're going to call it compounded quarterly, is it actually builds faster. Um, so 1% per quarter would actually build it faster. This is the TBM solver, and I love this one because if there's a website called fncalculator.com, it looks very similar to this, um, but you can also download this on the App Store, the Google Play Store, or the iTunes Store, and it has this little logo here. It's financial calculators, and when you download it, you just want the TBM calculator. So there's actually a lot of different calculators in it, but we want the TBM calculator. Um, One note, the payment or the future value, and so that's or the present value must be negative. So that's one thing. When we solve different amounts here, if you're trying to find like the interest rate, um, and we're plugging, and we're not going to use the payment in this lesson, but in the next one, the present value or the future value, they have to be negative, because the TBM calculator is what it's doing is it has to say what direction the payments are going. So you'll notice that when you solve for things with this calculator, um, if you solve for the future value, it actually gives you a negative value when you plug in a present value that's positive, um, because the direction of the payment is different. So if I pay you, then or if you're the bank and I'm paying you, then presumably you'd have to pay me back, so the money would go back the other way. The annual rate as a percent, you just punch in the number here, but the periods, it's very clear that that has to be like the number of months, the number of quarters, whatever it is. So the compound interest formula by hand looks like this. So it is the same as an exponential percentage growth, but it does the 1 plus for you because everything is going to be bigger than 1. Money always grows. A is the amount of the investment in the future. It's also called the future value, so we'll use FV sometimes. P is the principal amount borrowed. It's also referred to as the present value. Um, so P as principal or present value actually kind of work. I is the interest rate per period as a decimal. So you'll be given a percentage. You got to convert it to a decimal, and it's going to be the amount per period. So depending on what the question's asking for, this first one's gonna be semi-annually. So you have to kind of know what it is per period. And N is the number of periods. It's not always the number of years. So N is like the number of periods. In the past, we probably would have seen it to be what we want it to be, which is probably the number of years. But in a case where you want to say like 5 months, it could be 5. It depends on the question. So the first question, we're going to compare 5 years, $1,000 invested for 8% per year compounded semi-annually versus 8% per year compounded annually. What the semi-annually means is basically kind of like in the warm-up. It's 4% every half year. So not 8% per year at all, but 4% twice a year. So the first one, if we draw a little timeline, so this is just from year 0 to year 5. It's just like a number line. What we do is we look at like the $1,000 at the beginning, and then realize that, and what the formula is going to do is it's going to grow by 1.08 every year. So to get the end of the first year, we multiply by 1.08. Second year, we multiply by 1.08, and so on and so on and so on. And then the formula allows you to do 1,000 times 1.08 to the 5. The 8% is the annual as a decimal, 0.08, and then we're going to do it for 5 periods. The semi-annual one, so we get 1469. The semi-annual one, we look for the same 5 years, except something is going to happen every half. So we start at 1,000. Instead of multiplying by 1.08, we multiply by 1.04. So 0.04 is your I value. And we're actually going to do that 10 times. So twice to get to the end of the first year, 2 more to get to the end of the second year, third year, fourth year, and fifth year. And so 1.04 to the 10, that gets you kind of in the same ballpark. You can see like you're going to multiply 1.08 5 times. It's kind of like multiplying by 1.04 10 times. But money grows faster. So compound interest means interest grows on interest. So you actually get $14.80, so $11 faster, or $11 more for the 5 years. But same interest rate, same 8%. It's just when you compound it semi-annually versus annually, it's $11 more. A couple examples: your grandma invests $5,000 to bank account for you on your first birthday. We'll just say that's when you were born. The account is 4% per year compounded monthly. How much will you have when you're 18? So once it says compounded monthly, what that means, we can't ignore that. It's 4% per year, but and then just the per A means per annum. It just means per year. And always interest rates are going to be quoted per year. But the compounded monthly means it's going to happen for months. So we don't care about years, we care about months. We don't care about 4%, we care about the percentage per month. So we're looking for the amount in the future. We have the present value now. The amount we do per month is 0.04 divided by 12. So divide by 100, then divide by 12. And the n is 216 months. So in the formula, we can plug in those numbers, and we get 10,259. So that's how much the money it's going to be worth after the interest grows. The next one, you've got an amount paid back after 2.5 years. So you're going to pay back $12.50 after 2.5 years. We want to find out the original. And again, it's compounded monthly. So everything is going to be in months. It's not 2.5 years. It's for 2.5 years, the number of months. So now we know A is the future amount, $12.50. We don't know the principal or the original amount. I is 1%, because it's 1% every month. And N is 30 months. So plug all those into the formula. Divide by 1.01 to the 30. That's very similar to like actually doing 1.01 to the negative 30. We know that from exponent laws, but that actually might be a helpful way to look at the formula when you're trying to find the present value or the principal. The negative 30 is kind of like going back in time. So it's kind of saying, all right, neither of these questions were starting at 5,000 or 1250, but here the 5,000 we're actually growing it. The 1250, we're actually going back in time. So the negative 30 actually brings it back. It's the same thing as dividing it, but I've always thought that that's helpful to think about like the negative as going back in time. And so we also expected a smaller number. The 927 will grow to 1250. So if we borrow 927, we owe 1250. But if you owe 1250 in 2.5 years, then you borrowed less than that because interest grew. Money always grows. P is always smaller than the A. Nazir saved $900. He borrowed the rest. 2 years later, he paid $1429.50 for the principal plus the interest. So that was the future value of the loan. Notice the $900 has nothing to do with the interest. So we're gonna think about the 900, but we actually don't want to think about the 900 as part of the loan. So when we do these questions with the formula, we're actually just looking at applying the loan or the investment, so the money that's actually going to grow, to the formula. So right now we have the future value of $1429. Present value is what you're looking for. It's kind of similar to the last question. It's compounded monthly, so again, everything's in months. So the interest rate is 1.5% per month, or 18% divided by 12, and it's for 24 months. Plugging everything into the formula. Um, I also like the negative exponent because it allows you to do this part in your calculator, 1.015 to the negative 24, and then multiply by 1429, rather than dividing where you'd have to do this divided by 1.015 to the 24. So the principal is 1,000. Um, how much the TV costs? Well, you could say like he borrowed 1,000, but he saved 900 as well. So the TV costs 1,900. The next one is asking you for an interest rate. It's compounded annually. So we've got $200 growing to $250 in 4 years. It's all in years because it's compounded annually. If it's a compounded semi-annually, you'd have to realize that your interest rate that you're going to get is actually going to be half of the annual rate. But you have all the numbers. The P is 200, the A is 250, the I is what we're looking for, the N is 4. So plugging all those into the formula, we can divide by 200, take the fourth root of 1.25. So that you can also do the exponent 0.25, which is like a quarter. You get 1.0574 equals 1 plus I, and subtract 1, you get 0.0574, so 5.74%. For each of these questions, you can actually try the TBM solver. So the TBM solver was back here. So if you've downloaded this TBM solver to your phone, what we can do is we can actually try out each one of these questions with this. So in the case where you have the interest rate, you just sub it in. Don't divide by 100. Don't divide by 12. Just sub it in. The periods, you still have to think about how many months or how many periods it is. But then whatever you're looking for, you just click on it. So present value is the principal, future value is the A value. If you're looking for the last one, you just click on the rate. Probably the trickiest one is the last one where you had 200 going to 250, because you have to actually make the future value negative 250, because again you have to, and you don't have to make the future value negative 250. You could make the present value negative 200, but they have to be opposite signs so that you understand that they're going in opposite directions. So if you've downloaded this app, you can actually check all of this work just one at a time with the app, and then making sure that we're comfortable using the app as well, because the app is actually what's going to be really useful, especially when we do annuities in the next lesson.